Hey guys, welcome to the first screencast of BIM Collaborative. In this screencast, I'm just going to go quickly over how to do basic piping systems and plumbing. And just to give you a little bit of background on who I am and what my experience is, I have over 15 years, almost 16 years experience in the engineering business, doing mostly plumbing, piping engineering, um, but I also have some HVAC experience and some electrical experience. So I think I have a decent breadth of knowledge, at least on how to do a project and engineer a project and create really good looking engineered documents. In my experience, of course, like all of us, if you're if you have 15 years plus, you've probably started on AutoCAD, and now this move to Revit is a big jump for a lot of us, and it's making us think differently. One thing that I missed out on was I went from AutoCAD 2007 and straight to Revit about 3 years ago. I never did touch AutoCAD MEP, which, if some of you did, you know that it has a lot of the characteristics that Revit does, like parametric objects and 3D drafting. But my first exposure to the 3D world was Revit. So I got thrown into using Revit exclusively at my last company because they wanted to move to Revit, but they actually didn't take the time to learn it. We had to actually learn it as we were going. And I think that kind of forced me into a unique situation where I had to meet project deadlines, but also had to learn um, how to use Revit and how to overcome a lot of the obstacles that you might find as you're learning Revit. And I think I found some pretty interesting tips and tricks that hopefully can help you guys. Um, but where do you start? If you have a decent amount of Revit experience, or at least some foreground in it, background, I'm sorry, in Revit, then you probably do know how to create some simple systems, how to do some routing, pipe routing, HVAC duct routing, electrical conduit, wiring, things like that. But what I'm going to concentrate on this first screencast is how to set up your piping systems and how to basically name your piping systems and use your tags to descriptively name those or tag those pipes. And this may be something that you know about already, but hopefully there's a couple of little things that I can cover that you may not have seen. One of the things I noticed about Autodesk products in general and Revit especially is that there isn't really a lot of material out there. You can Google different problems that you might experience with Revit along the way, but it's rare that you'll actually find a really good answer. A lot of the answers that I've had to come up with are things that me and my colleagues discovered on our own. So anyway, let's get to it. Here I have just a basic plumbing project. Um, Not much to it, but this is a good starting point. So you can see that what we did is we actually copy monitored these plumbing fixtures into the project. You can see that they're actually families now in here without any link to the original model. Just to show you what happened, I deleted that one. I'm going to actually copy monitor this fixture and just show you that it actually is really a 3D. Um, it actually really is a 3D object. But what we did is we have found that a lot of times, well, let me go back. We found that copy monitoring plumbing fixtures really can be problematic because plumbing systems are so finicky as far as like where fittings are placed and how routing is done, that if the plumbing or if the architect came back and actually moved fixtures enough, it could pretty much destroy the system you'd already put in place. And that's one thing we wanted to avoid. So what we actually did, and now that I'm doing this, I'm going to go ahead and go all the way with it because I need to show you everything. I'm going to delete what was already, I'm not going to delete the floor drains because we put those in. Um, we'll delete that. All right, so what I'm actually going to do is I'm going to copy monitor all of these, but then I'm going to drop the link so that we are no longer monitoring the position that the architect gives these fixtures, and when they do come back and make changes to the location, it won't mess with our piping layout. Just thinking a little bit here. Um, it's really important. We had projects before where the plumbing fixtures changed enough that it actually, when you're using slope piping, especially because slope piping in Revit is very finicky, and if you were to change the location of one fixture, it might actually force um, the piping to go non-sloped, which is really annoying. And sorry for the warning sounds. I probably should turn that off for the next screencast, but there we go. Those are all that I'm going to copy monitor for the moment. Now I'm going to select them all the ones that I've copy monitored, and I'm going to actually stop monitoring. So what that has done is that it's created an instance of that family in my plumbing model. As you can see at the top of the screen, this is called B912_plumbing. So this is actually my model, and these families are a part of my model now. They are not dependent on the architect's model. The one thing that you have to be careful with now that if you were to follow this approach, is that you would need to consistently uh, check your fixture locations with the architects. But this actually gives you the freedom now to make your changes without uh, automatically destroying the piping system that you've put in place. All right, with that said, let's go ahead and start creating a piping system. And now, where does a piping system actually originate in Revit? Now, domestic water is a little different than sanitary. The workflow is different. And what I mean by that is that sanitary actually rolls out from the farthest fixture to where you're going to bring the piping out of the building. And if I were to actually start from where the piping comes into the building, I may find myself too far above the invert of the fixture itself. So what I'm doing is I'm actually starting some sanitary waste piping. I'm going to slope this up because I'm starting from where it comes into the building. And this is just to give you an example. I just said that you wouldn't want to do this typically, but this is just to give you an example of what may happen. And I'm going to basically center that piping to the chase somewhat. Now keep in mind this model may not be realistic, but it is a starting point. And I just realized as I made that deletion of the fitting and spread those apart, this is one of the problems that you may run into with slope piping. Because I deleted that, and if I were to pull this back and I wanted to do a 45 to that piping, now see if I select the piping I created here, you can see that the sloping is at 1/8 inch. Select this piping, which is disjoined from the rest of the system, and you can see that that's at 1/8 inch. It's a little difficult to see because of the wall, but there you go. Now, if I were to trim these two together, look how the sloping changes. The sloping changes for this part because it's actually having to change different parts of the pipe and maintain a connection to it at a certain slope, but it can't keep that here. Now if I can actually select this, well, usually you can. I can change the slope of this to 1/8 inch and see, excuse me, I get that warning. The slope that you've specified cannot be applied to this pipe, and that's because we've separated them too far to actually maintain that slope. Now, I don't want to waste a lot of time with this, but that's just to give you an idea of how different the workflow is for sanitary than it is for domestic water. So let's actually start the way you're supposed to start. With sanitary, you would typically start at the fixture. You could for domestic water as well, but I tend to find that domestic water works better working in the opposite direction of sanitary. So we're going to start from the family. Now let's actually look at the family and see what connectors we have available to us. We should have one sanitary discharge from the fixture. And as you can see, the architect was so unfriendly as to not actually give us any connectors whatsoever. So what I'm actually going to do is I'm going to create my connectors. But before creating our connectors, we actually need to give it a face to draw the connector from. And right now, you may think that we would have some kind of face to connect to, but let's see if I do a piping connector. You notice how he has not actually given us a really good face to give those connectors to. So what I'm going to have to do is I'm going to have to create the face for those connectors. So I'm going to go to the reference level view of this fixture, and our drain outlet would actually be, what I've done is I've started an extrusion. I don't want this to be a very deep extrusion. It's just there for my connector, so I'm going to make it at 1/8 of an inch deep and the offset at 0, 0. And I'm making a circle. I'm going to just place it near about where I feel like the connector to go. And I know that I want the diameter of that connector to be 3 inches. So I'm going to set my radius at 1.5 inches. And there we go. We have a 1/8 inch deep, 3-inch diameter extrusion. And let me just show you what that looks like. So if I go and I turn around, you can see that now we have an extrusion that we can connect to, and it's sitting inside the model that they'd already created for that fixture, so it works out. I didn't mean to hit that. So now I'm going to create the connector for it. So I hit pipe connector under create. Let's create, go to pipe connector, and then I'm going to actually select that extrusion. You see how it lights up? When I select it, then it gives us this connector. Now I go to our properties panel, and you can see all of the different properties that are assigned to that connector. And what we know that we are going to do this system. This is going to be a sanitary system. So I set our system classification to sanitary. Our flow configuration will be fixture units. We know exactly what fixture units we're going to assign to a water closet. We want our flow direction to be out. Loss method, I'm not going to mess with that with sanitary. We're going to set our fixture units. This is a flush valve type water closet. So our sanitary fixture units will be for public flush valve type water closet, and that's at 6 fixture units. The diameter of the connector should match the diameter of the extrusion. I typically will make my extrusions the same size of the pipe that I'm going to connect to it, and then I need to make sure that my connector is that same size. So I'm going to make the diameter of that 3 inch. And you could also give that connector a description, which I'm going to do. I'm going to say sanitary, can't type, sanitary waste out. And we'll apply that. And now we have a connector to connect to. And I'm just going to deal with sanitary for, I'm just going to deal with sanitary for this screen test. So we're done with that connector, and we can now load that into our project. Or overwrite, I'm going to go ahead and overwrite the existing version and its parameter values, even though I haven't actually changed any parameter values. I just know that the family I was just working with directly has everything in it that I want. Now you see it updated every fixture. Now you see that extrusion. And if I were to go to 3D, actually I don't want to look at that version. Well, I'm going to turn off the link so we just see the plumbing. Now you can see, now that that connector is there for each of those fixtures. And it gives this little sign of a trap showing that it's sanitary. It tells you how many fixture units are out. And it also tells you, if you look at your properties, what system classification that is. And you know that because we just created that in the family. So now we know that we have a sanitary pipe or a sanitary connector on that family. So I just hit Control Tab to go back to my original view. I'm actually going to hit the X up here to close out any other views. I hate I hate looking up here and having so many views open, so I make it a habit to hit the X as much as I can to keep my views kind of clear, so that I know I can control tab between the ones that I'm actively using. Um, for example, I want to keep the 3D and the floor plan view open, and actually I just want to set this to fine so we can see the pipe. Now you see that the pipe is way too low. Um, I'm going to leave that alone for now. But anyway, so you can see that now I can control tab back between the only views that are open. Um, so I'm actually going to delete that pipe. We're going to start from the fixture. Now there's a couple of ways to start drawing in Revit. I found that once you actually get used to using Revit and thinking in 3D, which you should eventually, and actually very quickly, surprisingly, um, you actually want to start drawing in this view as much as you possibly can until you actually have to switch to um, the 3D or elevation view. But to begin with drawing in Revit, I actually really had to start thinking in 3D because it was something that I hadn't done yet. So um, I'm going to create an elevation view. And I went to view and I hit elevation. And what that does is it brings up this little symbol, and you can change the way that looks. I'll show you how to do that later, but I want to rotate this view, and hopefully you guys are familiar with how these work. But the little arrow, if you click on the arrow, it shows you the clip area for this elevation. And now what this means is that this blue line out to the dotted line is the area that you're looking, and the direction that you're looking is it's like you're standing here on this line looking this direction. So I only want to look at those two water closets. So excuse me, I'm going to move this line here. I'm only going to look at these two water closets. So if I right click on the arrow, you can actually double click it as well, but I just want to right click on it. I do want to show you that we are on the right level. This building, the level for the floor that we're doing this work on is actually on what they're calling level 3, which is weird, but that's where it is. And I will take that back. I cannot show you the levels right now because um, this template was not set up to show levels very well. Now, what I was saying before about how this isn't a very realistic model, you can see that the architect really hasn't given us very much room for piping. 2 inches. That won't handle our fittings. So anyway, back to creating a system. Okay, we are going to start a pipe. And actually I want to be in fine view so that you can actually see the pipe. And the pipe type is called sanitary waste. Now, how did I get that? If you go to your project browser, go down to your, go down to your pipes, pipe types. You'll see that you have all these different pipe types. Now, some of these I've created. You may not see these in your default models, and I think, in fact, you will only see standard and maybe chilled water in your default models out of the box templates. What I did is I actually took one of the defaults. Standard is a default, and what I did is I duplicated that. You can right click on it, then rename it, and we'll just call this sanitary waste for screencast. Okay, and then I'm going to double click. I need to turn those damn sounds off. Anyway, I double click on it, and we can go and change our routing preferences. All right, so we are creating our piping system type, our pipe type. So um, what we've done is we're setting the routing preferences. This is where we pick the type of pipe that we're using for the different pipe segments. So just for a pipe segment, I am setting sanitary to polyvinyl chloride, rigid schedule 40. I'm going to set my minimum size. I'm going to set it at 1/2 inch just for the hell of it. Um, I'll never use that size, but that's what I'm going to do. Okay. And then for my elbows, as you can see, I have a lot of different families loaded into this project, but I'm going to set this to a bin, PVC bin, schedule 40, drain, waste, and vent. That's what DWV means. Of course, all of you know that. Preferred junction type. Now, hopefully you guys know what this means, but typically piping, sanitary piping, or domestic water piping, the way that things will cross each other is in a T formation. And we're going to set our junction type to a, you have to kind of think about this a little bit. How do you want sanitary piping to cross each other? You might want to use this combination Y and eighth bend, which is more realistic. But in reality, when you're actually doing your pipe routing, that family doesn't really deal well with sloping. At least it didn't in Revit 2010, 11, 12. And now that I'm working in 14 now, it may actually work better, but I just feel a little bit more comfortable dealing with the reducing sanitary T. And then if I need to, I can change it to the combination Y and 1/8 bend later. Um, Cross, same deal. I will uh, I will set this as my reducing double sanitary T. And the reason I don't use just a double sanitary T is just because you don't have the flexibility that you do with the reducing double sanitary T. And a little bit of this decision making was experience with dealing with the older versions of Revit. And like I said before, 2014 is probably a little bit better at dealing with the Y and 1/8 bend. But I've even found in projects where I really was using the Y and 1/8 bend exclusively, I was better off choosing these two junction types as the reducing double sanitary T, just because it was a little bit more flexible. So that's what I'm going to set that on, and maybe we'll run into an example later where you can see that. But reducer will set that to a PVC schedule 40 drain waste and vent union, self-explanatory. And so there we have our piping system set up. We're calling it sanitary waste for a screencast. Now you could give it other identity data, but I'm not going to mess with that right now. You could give it cost, but later on another screencast will show you why this cost number without a formula kind of is um, kind of a misnomer and misleading. So we're going to start our piping system. You choose which one you want to start with, and I'm going to set this to that pipe type we just created. And I'm going to just draw this down to an arbitrary. I'm going to set my sloping down because we want to actually turn from the water closet and go down. And as you can see, I've got my slope at 1/8 inch. And now I might even move that pipe up just a little bit. Actually, you can't see the slab right now. Let's get that in. It's actually shown, but I don't know why. I don't know where it is. Maybe the architect didn't show it. Again, this is a faulty model. It's not perfect, but this is just to show you how to create basic piping systems in Revit. So you may, let me just preface the rest that I'm going to do with this piping system with this statement that with a well-developed family library, your creation of these systems and the routing and all that stuff may be a little bit more dependent on the family that you've actually created. You may want to actually have a family that has all of this stuff built in already down to a certain point. Let's say that we know that our slab is 6 inches deep or 4 inches deep, however, whatever it is. You would want this rollout to be just a little bit below the slab, and it would roll out to your 1/8 inch slope pipe over to this, what this would actually be, because we have back-to-back fixtures, this would actually be that Y and 1/8 bend. So what I'm going to do is I'm going to extend this out a little bit because I know that that Y and 1/8 bend actually takes up a good bit of space. So I'm going to select that, and I'm actually going to go and actually choose the Y and 1/8 bend. So now you see that it has changed that fitting for me. And now you see if I select the fitting again, I have a plus on the other side. What did I do wrong here? Okay, this needs to be a Y and 1/8 bend double. Let me load that. I'll load the family, pipes, fittings, PVC, schedule 40 socket type, oh, drain, waste, and vent, and then we'll go back to our, see now what happened is I didn't actually have that family loaded. So I'm going to go ahead and load the, I'm going to load the Y and one, combination Y 1/8 bend double. And that's loaded into the family. See, it wants me to place it somewhere, but I'm actually going to select the fitting that I already had there, and I'm going to change that to a double. Now we've got what we're looking for. Okay, now I can actually, I'm going to work backwards this way. So with this fixture, I drew from the fixture connector, and I drew over to my fixture stack. But with this one, I'm going to draw in the opposite direction so that I can keep my sloping consistent. And I'm going to start drawing the pipe. What I did, if you're not aware of this, is I select the fitting, right click on where I want to actually draw the pipe, and I'm going to draw, and I'm going to select my slope to be up. And what it should do is give you this little dotted line to show you that it's in line with the connector, but sometimes it's buggy and I don't like dealing with it. So I'll just draw it slightly down, and then I will actually start my other section from the fixture itself and then trim these. And there we go. We've got a perfect set of back-to-back water closets started with a sanitary system. And now when this pipe comes up above the slab, it's going to transition to a vent. And then this is what I was talking about when I mentioned having a well-developed family library. You may actually want all of this stuff that you see in your family library so that you have a set of back-to-back fixtures already in place that have all this done. And the reason I found that somewhat problematic, especially with water closets, is that um, the chase space may actually be different. The architect may not have given you the same space size as he did on the project that you did with him before. So I found that it's actually more beneficial for me to just do this method that I'm going to show now. So now how do I actually split this system? So what you see now um, is that I have a sanitary system started. So if I select the pipe and I go to the top ribbon, there's a tab called Piping Systems. And if I select the piping systems, I can go here and I can see that that system name is called Sanitary 1. Now, we all, as MEP engineers, we have our own nomenclature for the systems that we have in our projects. And sanitary, or I'm sorry, plumbing piping systems can go by various names. Here's where you can actually go and you can change the name of that system. What I typically use on my projects is I'll use SAN for, and actually is already in use. Here's how you manage your piping systems is through the system browser, and I'm actually going to pull this over and tab it with everything else. I am going to, just for the screencast, so I can get through this, I'm going to delete SAN. I'm not actually sure why it's there. I thought I deleted all the piping. So I'm going to select this piping. Now there's two ways that you can edit this system name. The one that I started to show you was go up to the ribbon and hit that piping systems tab, and then go to your properties uh, properties panel, and then change the name there under system name, and then apply, and there you go. Now you have a sand system. And this means a lot later. I'll show you when we get into filters and stuff like that for your piping systems. But for now, just know that I've changed that system name now to sand. And just as an example of what that does for you is I've created a tag. Well, actually, I do want a leader, but I want a free end. Created a tag that will tag that pipe with the size and the system name. And just quickly on how you do that, edit that family, go and select the label, edit the label, and you can see here I've chosen from a list of um, a list of parameters that are available to pipes, and I've chosen size and system name, and I keep them in line with each other with one space in between the size and the system name. And so that's what's important about uh, labeling your piping systems a certain way. If you kept it the default value, which was sanitary 1, because it was the first sanitary system, and that's what my tag is going to show. You may not want to use these tags, but this is the way I prefer to document Revit models. Anyway, so that's how you basically create your pipe type and your piping system. So there is more to it, and just quickly I'm going to show you um, what is involved with an actual pipe system. I'm going to go to my system, or I'm sorry, I'm going to go to my project browser here, and I'm going to go actually look at my pipe systems. So this is different from the pipe types. We have our pipe types up here, and we have our systems here. And what is different about these? Um, these have to do with the actual fluids that are flowing through your pipes, and it affects the calculation values in Revit. So I'm not exactly sure what the defaults are. I think that the defaults include most of this stuff here. I've added natural gas. What else did I add? I added filter water to this. This had something to do with being a template from another project. But if I were to right click on sanitary piping system and then go look at the type properties for that system, um, you can see that there's a couple of things that you can change here. Um, for sanitary, there's not a lot that you can do except for change your calculation types, and I'm actually going to set this to flow, and we'll get into how that works later. But you can change how your rise and drops look graphically. But I uh, I am actually trying to move out of the old school version of engineering documentation and into what I think is the new way to really show piping in a engineering document where I'm not actually using these symbols anymore. I'm using what you see here. Um, and I hope to actually kind of convince you that this looks a little better, um, but we'll get into that later. If I were to actually go and look at the domestic water system, if I go and check the pipe properties, you can see there's a couple more values here that you can affect, and you get your fluid type. You can change it to a bunch of different stuff here, and these are actually customizable as well. You can set your fluid temperature. This you're also when you go and you manage your fluid types and properties, you can set the viscosity, density, things like that. Um, we actually do want to set this value in our projects. If you have a predominantly flush valve project, which is the most stringent flow conversion method, if you have any flush valve fixtures in your project, or at least, like this project, we have two or 3 flush valve fixtures versus the other just standard fixtures. We're going to pick flush valves as our predominant flow conversion method. So you can see that there's a couple of more values that you can change here than you could on the sanitary. Sanitary is pretty limited. And just quickly, how do you manage those settings? You would have to go to your Manage tab, and then you would then go to your MEP settings, which actually are hidden because my screen's so small. Go to Mechanical Settings and go to your fluids, and here you can see there's all those fluids, and you can change these things. I'm not going to mess with that right now. We'll get into that more when we start actually using Revit to do some sizing. Just wanted to give you an idea of like this. This is all of what piping systems are about, and there's a lot that you can actually do. So back to where we were. How do we actually split the sanitary system from the vent system? Um, Again, there's a couple of methods. One of them is having a very well-developed family library, and then having those connectors built to the library so that they are actually different. But when the architect changes this chase size on you, it's hard to really keep a consistent family like that. And there's a couple of ideas I've been throwing around, and I'll show you this on other screencasts as a better way, I think, to deal with these. But just quickly, I'll kind of give you a glimpse of what that's going to look like. I'm going to select this family. I'm actually going to select all of this. I'm selecting everything because I am very confident with this filter feature of Revit. I don't want to select the connector element. I want everything except for the connector element. And there's this visibility setting. If you go to your properties panel after selecting those things, what I'm getting at is I want to hide the fixture itself, because I may want this to become part of my standard library, but I don't want it to look different from what the architect has. But at the same time, I want to use my standard library families and keep my connectors and all the stuff the same that I'd already used. So I can select all of that stuff and go check this visible thing. And I'm actually going to add a parameter here, a type parameter. This is important. If I were to select instance, it would mean that that particular instance of this family in the project would have the settings I gave this parameter. So what I'm going to do is I'm going to set it to type. I'm going to call it show plumbing fixture, and you can name it anything you want to, but I want to put that under the category of visibility. And so now all of this stuff is associated with this parameter called show plumbing fixture. And if it's checked, it means it's visible. So I'm going to load this back in. And now this is a point where it's very important to overwrite the existing version and its parameter values. Now I'm going to select this fixture. I'm going to edit the type, and I'm going to go down to that value, show plumbing fixture, uncheck it, and now that fixture shouldn't show up. And something's funky going on here, but this is the way it should work. I go to, well, it's still showing up, but you get the idea. There may be some stuff in the family. When that happens, typically there's some embedded objects in this family that have to be fixed. I probably need to explode. So I'm going to uncheck that. Yeah, I can't even explode that. I check that. Yeah, I'm not exactly sure what's going on with this. Anyway, okay, I don't want to waste your time with this, but the point was that you could actually build a family library where the fixture itself was not visible. Um, only only the piping that you had created for that family was visible. But anyway, the next point of creating the sanitary system was how do you actually separate the sanitary piping system from the vent piping system? Because as we know, the sanitary and vent piping systems are connected inherently. So how do we actually separate this? Well, what I've created for these custom type setups like this was a family that could be used as a connector type, fake dummy type fitting. And I called this a universal connector because it is capable of taking on properties of any kind of system. But um, I'm just going to edit this family so I can show you what it looks like. Um, Basically, that's all it is. It's an extrusion with fittings, or I'm sorry, connectors on each side that, as you can see in my properties panel, the bottom connector is called System Classification Sanitary. I don't worry about any of this information because I'm not actually I'm not really doing anything as far as fixture units and stuff from this connector because you'll see where it's placed. It doesn't really make any sense to do that. The top connector is called vent, and that is actually already loaded into my project. So what I'm going to do is I'm going to insert that here on top of the fixture stack. And where it defaults to is offset at 0, 0. I'm actually going to set that at 3 inches above the floor. And there it is. And then I'm going to set its nominal diameter. Now this, I'll show you how to get into affecting the dimensions. There's a better way of dealing with this than the way I've done this. But just for the screencast, just so that I can show you how to separate the systems for now, I'm just going to use this family as it is. So now that's set. Now I'm going to go back and look at my elevation view, and you can see where that family came into place. So see, it's 3 inches above the floor. It's directly centered over this fixture stack, so I should be able to connect this pipe to it. I'm just going to drag it up there. And now if I select that, you can see that it's actually been put on that system. Did I not rename this? All right, I need to rename this back to what I wanted it to be. San. If I select that family, you can see it's still San. Now, with that family selected, you can see that I have two different types of connector options here that I can draw a pipe from. One is sanitary, and it's grayed out because it's already connected, but I have the vent that is not connected. So I'm going to select that to draw a pipe from it. And you can see that it's set on a pipe type, the last pipe type that I drew from. As I draw it, I'm going to go ahead and set this to the sanitary vent pipe type that I'd already created, and the system type should be vent. So I'm going to draw this up into the ceiling space, and I'm going to go ahead and pull it out a little bit, sloping up. Again, you want your vent piping to slope it at 1/8 inch. And there you go. So now we've got two separate systems that visually look like they're connected to each other unless you get in really close here. But that's it. That's how you separate those systems. That's one way. There's probably better methods, but this is the method that I have used for a while that I think works fairly well for me. And you would think that this seems a little bit complicated and takes a lot of time to do, but as you get used to using Revit, you're more fluent with the controls and using the different views. It actually becomes a little bit more simple. And in fact, if I wanted to, oops, I mean to grab that. If I wanted to, I can grab all of that pipe, including that connector, and go back to this view. And I don't want this side, but I'm not going to worry about that right now. And I'm actually going to copy that down. And you can see it will automatically try to align with the reference line that was given in this water closet. So basically, I did that once, and now, sometimes it's hard to select the fittings. I did that once, and I can actually copy it down and use it for the next set of fixtures. But as you can see, I deleted the other side of that Y fitting, so now I've got just um, this reducing sanitary T, which I actually don't want. I want to set this again to my Y 1/8 bend. And there you go. We've begun routing our sanitary. So now, just really quickly, I'm just going to route this out a little bit and just give a realistic real interpretation, or I mean version of what the system should look like. I'm going to draw the pipe down from that, and I'm going to actually slope down now. I'm going to draw it off a little bit here. And see how it automatically tried to connect that, which is fine. Really, actually don't want that. That is not per code. So we're going to change this back to that T reducing sanitary. And this should be the combination Y 1/8 bend. Now we have a more realistic looking system. And then continue that pipe. Continue it out to, actually, want to make sure I go ahead and have that 45 set in this so that we're, like I showed you at the beginning of this screencast, how that separation of pipe and drawing in a different direction can kind of mess with your invert a little bit, or your sloping. Then I'm going to go ahead and draw some pipe up this way. Oops, I don't want to go up. You get that warning because I was drawing pipe down instead of up. I want to draw up because I'm going to a clean out. And then I'm going to set my offset at 0 so that the pipe's even with the floor. And I actually don't have that in here yet. I'm just going to set it 0 and hit apply. And there you go. Now you saw before that I drew that vent and actually had it coming out away from the fixture stack somewhat, or the vent stack. But you don't see it here, so where'd it go and why don't you see it? It's because our view range hasn't been set to where we can see it. I know it's probably up above 12 or 13 feet, so I'm going to go ahead and set my top range at 13 feet, and there's that pipe. Now here's where there's a little bit of a decision making that needs to be made as far as how you're going to actually document and what's the difference between modeling and documenting. And I actually like to maintain a little bit of that schematic type of setup for documentation rather than going completely realistic always. But that could be a preference, and it also could have a lot to do with the project you're actually working on. For this project, I actually do want to be as realistic as I possibly can. So this vent piping would actually realistically just sit on top of the sanitary pipe, but up, in the ceiling space. May even actually be down low in the chase. But as you can see, I'm gonna go ahead and draw out to a vent through roof. Draw pipe. We're sloping up at this point, and then I'm going to draw this up to, I'm going to say, I'm not sure where the roof is, but I'm just going to give it an arbitrary value. And there you go. Now if I were to come back and tag this with, actually I don't want it at 1/8, go to 1/4. If I were to go back and tag this stuff, you can see that, there's sanitary, there's my vent, and I haven't given this the proper name yet. I'm going to go back to my vent. I like to call vent V, 3-inch V, 3-inch sanitary. And there you go. That's the beginning of a piping system that's sanitary, split away from your vent system. And documenting this, you wouldn't even, you would see this. It's somewhat, I mean, it works for our purposes. But as you can see, that visibility values taking place right there. I can't see the plumbing fixture. And there you go. The next screencast, I will go into more depth on this. We'll cover the domestic water system, and there's some interesting things to do with your fluids and stuff like that. But hope at least that one little tip on doing the universal connector helped everyone, or gave someone a good start on this kind of stuff. And again, like I said, having a well-developed family library can help circumvent a lot of these little weird tricks that you have to use. But under a crunch, this actually works pretty well, and this is what I've been using for a while. Um, the companies I've been working with haven't really had the time to develop libraries that extensively that we've actually been able to draw these connectors into everything. Um, as a lot of companies are, we're probably playing catch up for the most part because architects have been using this software for quite a while, but MEP engineers really haven't, especially smaller companies. So I hope that through these screencasts, I can give you a couple little tips like this here and there that will help you catch up pretty quickly. And um, what I hope to cover in these screencast series is how to actually draw this stuff, how to actually model these systems, and show you all the little tips and tricks that I've found along the way. And then um, in the end, we're going to actually have a fully designed model and a fully documented set of drawings. And in the future, I will actually include uh, the files for this stuff, and you'll be able to download them for your use and follow along with me. Um, but I hope that helped, and I hope that you guys come back, and I hope to really create a good community here, get some feedback from engineers that have been using the software. And if you found things that work better and you're willing to share with everyone, then please feel free to comment, and I would be glad to incorporate those comments in future screencasts. So thanks for checking me out, and I hope you enjoyed it.